Today we're going to learn about
Light Refraction!
Hello everybody. The first step of our scientific method is observation. What do you see here?
I see a red and blue line and two blue arrows.
What do you notice about the arrows?
They're opposite. So one's this way and the other's this way.
The second thing we do is we ask questions.
So what would happen if?
I have an idea. What would happen if we poured that water into the jar so we could see?
Once we pour our water in here, we're asking what would happen with the red and blue and what would happen with the arrows, right? Mm-hmm. What about what happens if it's up against it or if we move it back some?
Okay, can we do both of them?
Mm-hmm.
The third step is to make a hypothesis.
Who remembers what a hypothesis is?
Hypothesis. I can't know that. Hypothesis. You brainstorm ideas.
Right. Do you think first we should see what it looks like behind just the jar?
Yeah.
What do you think our lines will look like?
I think it'll look kind of wobbly and big.
What about our arrows?
I think the sticks would look wobbly, then when they got to the top, it would all kind of big.
So what about when we pour our water in and it's touching the back of the jar?
It's going to look bigger than
And then what about when we hold it back behind the jar?
I think it's just going to look bigger.
Just bigger than any of the others?
Well, no. Smaller.
You think it's going to look smaller?
Sorry.
Now we get to test our hypothesis. So first of all, we have our red and blue line. So,
whoa, it is kind of wobbly. And also, wait, it's not too wobbly,
but they're pretty close to the way they are, right?
yeah.
So there's not too much change. All right, now,
Oh, no, the same too.
not much change. Maddox, do you want to come be my assistant? All right, so what you're gonna do, Maddox, your job is you have to hold this really still. Ruben and Eddie, your job is to watch as I pour the water in. Okay, watch closely.
They get a bunch. Whoa,
What
they're
happens?
so much bigger.
On the bottom, we see it bigger. The top, we see it smaller. Okay, so now we get to see our arrows. What do our arrows look like?
They're huge.
They're huge.
They're very, very long.
Anything different this way?
Whoa, they're fat. They're stout and fat.
Do you know what we call that?
Magnifying.
Magnified. Like you're looking through a
Magnifying glass.
magnifying glass, right?
I said it, tell us.
I'm going to hold them this way. What do we have?
Red,
Red and then
blue.
blue.
We're getting a bit more water.
So I think for this next part, we need to fill up our jar a bit more. So we have
Red,
red and then blue, and they're long and skinny, right?
Yeah.
So what happens?
They're fat. They're fat. I can barely even see red. Wait, it's blue and then red.
So what side is blue on?
It's blue's over here.
And then
red.
And then red? It switched?
Yeah.
Red and blue.
Blue and red.
Okay, what about our arrows? Okay, so we're gonna try
Up and down.
up and then down.
Up and down. Down.
Our arrows flipped and our colors flipped.
That's weird. Is it magic or is it just science?
And that's what we call refraction. So when our light refracted, first it magnified it, right?
Uh-huh.
And then it actually flipped it.
Uh-huh.
So let's look. Does this...
It's like this. It's like...
Yeah, it doesn't line up, right?
Exactly.
When our light wave comes in and hits our water, does it keep going straight? No, it hits it and it bounces a bit. It refracts.
So light is traveling at the speed of light, and then it hits the water. That makes the waves slow down. It causes the wave to bend, the light to bend, and then it reaches the focal point, which is the center of the bend, and then it causes the waves to switch sides. So they're going like this, and then they switch sides. And then also it makes our pictures like this. It makes them switch sides. Thank you for watching this video today. I hope you watch our next one, and hope you have a good week.